And this is an upgraded version, kind of a fine-tuned version of the manual we have on our web page, which actually I will update someday as well. So we call it the visual manual, which can be accessed through our web page. So as I said, we'll try to make it, and I have time until 4:15, or is it 4, James? 5 past. 5 past.
Until
okay.
5 past, yeah.
5 past, okay, half an hour. So give me a shout, James, if I'm running low in time. Okay, so what I'll try to walk you through in here is to go through GUI mostly. The GUI is as it is. I think it's quite heavy and it's not, very modern way, and it could have been more pleasant, but that's kind of on a purpose. We're not investing too much time in making the GUI nice, because we try to encourage people to use the API. But of course, you're free to, you have all the functionalities in GUI, and I'll walk you through that. So the first thing, in order to access BHTOM, as I said, it's free, but you have to register, right? So the registration is straightforward, and I encourage you to, if you haven't done so and you're interested, you can do it now. I can take it slow now and describe things you have to do, but in general, this is the time you could use to register, and the things to do in a regular sign up is that you need to come up with your username, add your first name, last name, your email, come up with a password, and then we ask for a LaTeX version of your name. So this is, in my case, I have this L with a dash. So I want this to appear on publications. This is what this is for. If you write a publication, it's almost there. We would like to generate the author list using the correct spelling of your name. So that's why it's there. And then the affiliation or name of your observatory and the address. And then you can write a few words about yourself. Who are you and how did you find out about BHTOM and why do you want to use it? And then if you have our seed ID, you can add it here. It's not necessary. Yes, as I mentioned, so we need the LaTeX versions of your name to add you in the correct way to the paper. That's why it's emphasized this here. Right, and then once you register, you hit register, then you have to wait for an email from the administrator that I essentially go through. I receive an email as well, and then I can verify that you're a human, and then you're in. This is very common in many systems. So the registration. I don't see anyone registering now. I assume many of you have already done so. So if you want to follow me and do the same, or you can just watch my presentation, or as I said, you can go to the web page and browse through it yourself. So the main page after you log in to go to is the target list. So you go to the targets, and then you click list, and then you get the map of the targets, which are currently interesting. I see I'm approving Sarah's account. Just a second. Beautiful. Okay. Okay, Sarah, you're in. Stephen, just give me a moment. And Stephen, you're in as well. Good. So we use the Aladar map, which I find brilliant, that you can embed it in our system, and we display the Mellinger map of the Milky Way. And you see that this is an interactive map where you can click on the targets wherever they are, and that can bring you to the target web page. And this is an interactive map. You can change from galactic to equatorial. There is moon location. there is sun location. You can change to other wavelengths. You can turn on the grids and so on. This is the standard, all the features of Aladdin. Okay, and then you get below that, you get the list of targets. And one comment I need to make here is that by default, the warning there is saying that we show the targets with importance more than 0. So the importance is one of the parameters of the targets we have in the system. It's been evolving over time, but typically we assume that if a target has an importance more than 1, importance goes from 0 inclusive to 10, and it could be any fraction as well. But if it's above 0, it means this target is meant for observations. But if the importance is 0, the target doesn't need the observations anymore, right? So that's a good thing to remember. If you're looking for targets you would like to observe, then by default, the first page gives you the list, which is already filtered through, and the targets for observations are only listed. Because as I said, there is something like, at the moment, there's like 6,000 targets in the database. So if you display it on the map, you will see the whole sky covered, essentially. That's why we applied this filter by default. And some people actually use BHTOM only for the archival search, actually, to be honest. And we had a paper recently where people looked through, used BHTOM to extract all the archival photometry. They did not request any observations. So that's another feature of BHTOM you can use to have a unified access to all the archives, time domain archives. And you can do actually very nice science with it. Just a second, I'm approving James now. There you go. Okay, so the targets are listed by the time they were created. So they have the importance here. Then there is the last magnitude. So this is the last reported magnitude, which is more or less standardized to Gaia so that you can sort by this magnitude. Because, we have different filters, magnitudes can change over time, but also filters. So if you want to sort it by magnitude, current magnitude, then this is useful. And this is the last filter of the last observations. And there is also priority of a target. So this takes into account the importance, but also how frequently this target should be observed. And you can sort by that, because you can have an important target which has to be observed every week, or you can have an important target which has to be observed every hour. So the priorities will be different for these two. The sun column, it gives you the angular distance to the sun, which is a very approximate measure of the visibility of the target. Typically, anything above 60, 70 degrees is observable now. As I said, we serve the whole sky, right? So at this moment, this is not observatory specific. This is the whole sky. And then the last column is just showing the class. Sometimes, very often, we don't know what this is, and we say unknown, but sometimes we do. Okay. Yeah, as I said, so yeah, all this is described, and you can click on these columns and sort by this. Okay. And then at the bottom of that page, you have the filtering, and you can apply some filtering to that target list. So you can filter by range of coordinates. For example, if you specify minimum declination of 0, then you will only get the northern targets. And then the importance, as I said, if it's above 1, it requires observations. Typically, 4 is a good number of the targets which are important enough to be observed. And then the sun separation, visible now, more or less 60 degrees. And then the last magnitude, so you don't want targets fainter than 18th magnitude, for example. When you hit such filtering on the web page, you get the update of the page, and you get the map and the list of the targets following your criteria. So I could propose a short exercise here. You can choose from any of these, or you can do all of these. Let's spend 5 minutes playing with it if you were following me on the page. So you can find targets which you can find by name. So these are a couple of examples of targets which are nice and worth viewing. Or you can search targets by condition. You can search targets brighter than by 14th Mach and important enough and far from the sun. But also you can query by classification. There are two fields actually. There is a classification which is an enumerator, but there's also a human readable description. You can look for this description. Yeah, I see a question. Is there a question? No? Okay, disappeared. Okay, 3 minutes to play with this. Give me a shout if you have any issues with that. Right. I think we should move on. So I hope you managed to succeed and play with it a bit. So that's the basic actions you can do, and you can play later with that as well and find your own favorite targets. Okay, there is also another way of displaying. It's something what I call visual list. There is also a filtering you can apply, and then you can immediately display the likers of the targets you've selected. But be careful with that because generating these likers takes time. So if you want to display, for example, quasars, there's quite a lot of them. So make sure you define the criterion that there's no 100 quasars to be displayed. Oh, you just have to be patient. Your browser might not handle that, but that's another way of very quickly checking, displaying in one row, one column, essentially, row by row, the events, the objects, the targets, to see what are they doing at the moment. And then you can click, of course, and then you can move to targets. Just a quick note on creating the target. So in targets create, there are three ways of creating targets. So one is manual, then there is import of a longer list, and then there is a catalog search, which the latest one is the most convenient. I'll just quickly show you. So the create target form is you specify the name, the coordinates, the epoch, classification, description, then discovery date, importance between 0 and 10, and the cadence this target needs to be observed with. So, for example, if your target needs to be observed every week, then you say 7 days. So optimal cadence for observations. And then you can, if you know any other names of this target, then you can add them here. Although we run this automatically, right? So you don't have to do that. You can update it later. And once you specify your array and deck, we'll run through all these archives listed there, and we will identify all other names of that particular target. So that's the import. You can just upload a file and it does everything for you. And then the catalog search is probably the most helpful because you can specify just the name of the object in Gaia Alerts or Antares or TNS or even Simbat. And then if it's found on in these archives, then it's the create form is then filled automatically with the name, the coordinates, and some descriptions and so on. So this is the most efficient way of creating targets. Once you create the target, this is the target page, and it appears empty at the very beginning. It has the finding chart, all the basic information, but then if you refresh after a minute, then everything appears. So we in the meantime, in the background, we query all the time domain data. In this case, you see there's Gaia data, there's NeoWise data, and we fill all the other information. And then we also query the archive so we get the other names of that target. By the way, you can access the target directly if you know the name. That's the address of the direct link to that very target, which is shareable. You can share it with others more quickly. There are things like constellation, for example. There is automated classification. Sometimes it's correct, sometimes it's not correct, but that's to simplify, to help people decide what the target is. And there are external links to other archives as well. You can play with this plot, of course. It's an interactive plot. You can zoom in, you can select different observatory data, and then you can download the data here. The photometry data. If there's radio data, you can also download the radio data. And then at the very bottom is the most recent photometry sorted by date. And at the very bottom, there are comments, and we note who created the target so that we can then go back to the person. Let's call them a PI of a target, right? So if you created your target, then we'll ask you, okay, so this is the target you created, so you're in charge, right? So make sure there's data collected, the target is updated, and that the target is then possibly, used for some science. Also, you can specify, then you can add some additional information that the spectrum was taken, for example, and the comments on how do you want the target to be observed. And on the other hand, if you're an observer, then check the comments if they tell any more details about that particular target. Some targets might have some special requirements. So this is the comment field is used for that. Okay, and then you can display the light curve. This is an example light curve of Gaia data, archival data. You see there is data from pre-2000 for the target in infrared, for example. And you can play with it. You can switch off and switch on particular filters. So the first plot is by filter. So if this is 2MASS, this is 2MASS. This is NeoWise. There is Gaia in its own Gaia filter, but an Atlas as well has a peculiar filter. But all the follow-up observations, they are standardized to Gaia synthetic photometry, Gaia SP. So for example, U, G, I, R, these are the follow-up observations collected by the telescopes. That's another example of a light curve. You see multiple bands, multiple filters. Then below that, there is a different way of displaying the light curve. It's per facility. So we want to distinguish, which data comes from which program, which archive, but also which user. So here you see that we color-coded each observatory, each user is color-coded with different color. So you see, there is Uliana using 2 telescopes, for example, and she has 2 different colors. There is Danish telescope from Yaroslav, for example. You can actually select these data and then see what kind of data points were collected, which means that then each data point has a label. You see there is a date, there is MJD of the observation, magnitude, filter it was calibrated, and then the name of the observer, right? This is Staszek Zoła in this case with prompt 5 observatory. So if you hover around the light curve, you can actually see the actual names of people who contributed to that given data point. So if your data has been processed, it appears on this light curve, then you can have a look. You can see your points where they are on the light curve with your name on it. And then each point like this, it's an interactive plot. It brings you to a data product page. I don't want to spend too much time on this because this is getting we're getting late. But this is the page where there are details about that particular observation. So here you see details of when it was uploaded, how was it standardized, what was the magnitude, what was the 0 point found, what was the scatter of observations. The figure here on the right, it shows the way we try to identify your filter. We've identified the best matching filter for your particular observation, that particular observation. And here you see we found that Gaia synthetic photometry B band was the best match to that particular observation. You can actually figure out how do we do that. We compare the archives with your observations. So this is done automatically. Yeah, there's some details. I don't want to spend much time on this now. There is another tab called ccdfot. This is the actual the ccdfot is the name of the pipeline we use for processing feeds files, and this is the outcome of this pipeline. If there was a feeds file uploaded, then you can see the details on the object, including on the image. Sorry. And you can see the thumbnail of this particular object. There are models. Yeah, I'll just skip through that. And archives. Let's skip through that. There is also another tab for publication in the target page where we list all the data, the statistics on the observation. So if your name was one of the contributors to the light curve, your name will appear here in this table. You can then, with one click of a button here, you can download the LaTeX version of the table, which can then be copy pasted into an article. That's how we produce papers these days. Okay, so how to upload a feeds file? This is probably what most people are interested in. So then we do it per target. So if you observed one particular target, you go to the target page, and one of the sub-tabs, is called Manage Data. And there are different ways of uploading the file. So you can upload this extractor format. If you do photometry yourself, we can also handle that, and when we can standardize it. If you submit the data in this extractor format out of your frame, we can process it and standardize it. Then the photometry in CSV file, essentially your time series, it will not get standardized. We assume it's standardized. It will appear on our light curve, but it will be as just vanilla the way you upload it. Feeds file is the feeds file, the calibrated feeds file you want to upload. And you can also upload spectroscopy, but that's on a different matter completely. If you want to process the data, that's probably also of interest to many. If you want to be able to submit your observations, your feeds files in particular, you need to add your observatory to the system. And this is a very brief introduction how to do this. You go to the observatory main tab, and then you have a list of observatories. There is a favorite observatories and then observatories. So the telescope you want to upload for should appear in the favorite observatories list. If it's not there, then you can go to observatories and you can look through the list of telescopes we have, and you can choose from them. If your telescope is already listed there, is registered, then you can add it to your favorites, and then you're ready to go straight away. If the telescope is not on the list, then you have to register it. And you click Add New Observatory, and the new form appears, which is creating the observatory not yet in our database. So it's a fairly complex form, but I think on the other hand, it's kind of self-explanatory. You can add an observatory if you process the data yourself, you do the photometry yourself, then you can just give the name, the coordinates, and mark this only instrumental photometry file. That's it, and you're ready to go. The telescope, we will not process your feeds files, but we will process your instrumental photometry. But if you want to process feeds files, then you need to go through this form. You need to give us the details on your camera. standard things, as you can see here, and you need to upload an example file, right? We need to look through your header, you need to look through the structure of your files, just to make sure we can process your data. And then you create the observatory. This goes to our tech team, our experts who are looking through the file, and if everything works, then your observatory becomes registered. Okay, so as I said, dark bias, dark flat, corrected feeds files, and your observatory has to be registered and activated. You'll get an email after the observatory is approved. Okay, once it's approved, then you can go to feeds file, manage data again, right? Target page, manage data, and upload. And then feeds file, select feeds. Then you can test it. Dry run is just to test things if you want to see if it works. Then you can add observers. If there is more people involved in that particular data point, you can add them. They have to have an account in BHTOM, of course, but you can add them. Then you select your observatory. It has to be in your favorite list. You select camera. You can have more than one camera, by the way. And then you just leave the filter to any, and we will automatically get your filter standardized for that image. There is a note here. You can read that later if you want to do more advanced things. This is for instrumental photometry. I'll skip that very quickly. And then essentially in my last 4 minutes, I just wanted to show that there is this API. Essentially all functionalities can be are available programmatically, including uploading feeds files, extractor files, spectroscopy. You can get the target list, you can filter the target list. Everything we've done, for example, today, playing with the target list, you can do it from Python level. And you can download the data, you can download the details on the data products, so you can upload feeds files and see what's the result. And you can download the standardization results, you can change, add observers, and so on. In order to do anything of these functionalities, you need to have your API token, which you can, in the documentation, we say how to do that, but also you can get it from GUI. If you go to your profile in the BHTOM page, you can copy the token to the clipboard. So this is essentially the token, the very long characters, crazy characters, which are unbreakable, let's hope. And then you use this in your Python scripts. So I've created a couple of notebooks on Google Colab, which are linked here. I'll paste the link in the chat as well, but we don't have time for this anymore, I'm afraid here. But these notebooks are kind of self-explanatory. If you want to explore this more, play with it, you need to make a copy. You just copy the notebook to another Colab or to your own Jupyter notebook, wherever, or download this as Python files. One only thing you need to add there is the token, and then you can play with the scripts provided there. The newsletter groups, I already mentioned this, and that's essentially it. So just a note on this is the Google Drive with the API examples. So you can, let's start with this one, target list. You can essentially get the list of targets which are specifying some criteria like name or coordinates or magnitude. You can get that list through that script. You can download photometry. This is an example of downloading photometry for target. Then you can get the statistics. If you've been uploading some data, you can get the statistics from your telescope. And the one here, this is where you can. This is selecting targets for your observatory. So this is probably most useful. So here, the only thing you need to set up in the very beginning of this notebook is the name of your telescope. This is an example here. The latitude, longitude, and elevation. And then you specify your magnitude limit, where you feel comfortable with, and then the air mass, how far you can reach. And then the importance limit, as I said, it's safe to say it to 4. So everything above 4 is of high priority for observations. Essentially, once you set these things up and you run the script, in the end, what you get a HTML-like version of the list of targets which are currently visible from your observatory. They specify your criteria for magnitude or wherever, and they are, you see the classification here, some comments, and essentially they're sorted by some kind of priority, internal priority to this very script. So if you just go from the top, you observe this target, you know that you're contributing to a target which is now currently of interest. Or you can select your own targets through AstroColibri, for example, right? But this is a good place to start. You see, it's quite a long list because we said we can go down to 20th magnitude, but you can fine-tune the list and specify your own criteria as well. So I think this leaves you, it's 5 past, so I stop here. So I think I hope I gave you all the tools required for you to start using BHTOM, whatever you are, you're interested in a target, or you have a telescope, you'd like to connect this to other tools. And I think this is something what I learned from this workshop as well, is that there are other tools we could easily connect with BHTOM. For example, we can have the VO compatible protocols in BHTOM, which are transmitting the list of targets, for example, for your telescopes. I stop here, and yeah, thank you very much.
Thank you very much. I guess it's very comprehensive. It's amazing to see all the results you've got already coming out of this. Looks really intuitive to use. Thank you. So yes, any further questions for Lukasz? Yeah, thank you for the link. Oh, one from Stephen.
Yeah, just again, the question, how difficult would it be to implement EduGain for your login, for your authentication and authorization?
Yeah, we've looked into ORCID login. We failed because it's you have to pay a lot, apparently. So EduGain, yeah, why not? I'm happy to look into that. We've been thinking of some more standardized way of logging in. So I'm I would be interested in that for sure.